Chapter 6 of The Concept of Nature. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by M.B. The Concept of Nature by Alfred North Whitehead. Chapter 6 Congruence. The aim of this lecture is to establish a theory of congruence. You must understand at once that congruence is a controversial question. It is the theory of measurement in space and in time. The question seems simple. In fact, it is simple enough for a standard procedure to have been settled by Act of Parliament. And devotion to metaphysical subtleties is almost the only crime which has never been imputed to any English Parliament. But the procedure is one thing, and its meaning is another. First, let us fix attention on the purely mathematical question. When the segment between 2 points A and B is congruent to that between the 2 points C and D, the quantitative measurements of the two segments are equal. The equality of the numerical measures and the congruence of the two segments are not always clearly discriminated, and are lumped together under the term equality. But the procedure of measurement presupposes congruence. For example, a yard measure is applied successively to measure two distances between two pairs of points on the floor of a room. It is of essence of the procedure of measurement that the yard measure remains unaltered as it is transferred from one position to another. Some objects can palpably alter as they move, for example, an elastic thread, but a yard measure does not alter if made of the proper material. What is this but a judgment of congruence applied to the train of successive positions of the yard measure? We know that it does not alter because we judge it to be congruent to itself in various positions. In the case of the thread, we can observe the loss of self-congruence. Thus immediate judgments of congruence are presupposed in measurement, and the process of measurement is merely a procedure to extend the recognition of congruence to cases where these immediate judgments are not available. Thus we cannot define congruence by measurement. In modern expositions of the axioms of geometry, certain conditions are laid down which the relation of congruence between segments is to satisfy. It is supposed that we have a complete theory of points, straight lines, planes, and the order of points on planes. In fact, a complete theory of non-metrical geometry. We then inquire about congruence and lay down the set of conditions, or axioms as they are called, which this relation satisfies. It has then been proved that there are alternative relations which satisfy these conditions equally well, and that there is nothing intrinsic in the theory of space to lead us to adopt any one of these relations in preference to any other as the relation of congruence which we adopt. In other words, there are alternative metrical geometries which all exist by an equal right so far as the intrinsic theory of space is concerned. Poincaré, the great French mathematician, held that our actual choice among these geometries is guided purely by convention, and that the effect of a change of choice would be simply to alter our expression of the physical laws of nature. By convention I understand Poincaré to mean that there is nothing inherent in nature itself giving any particular role to one of these congruence relations, and that the choice of one particular relation is guided by the volitions of the mind at the other end of the sense awareness. The principle of guidance is intellectual convenience and not natural fact. The position has been misunderstood by many of Poincaré's expositors. They have muddled it up with another question, namely that, owing to the inexactitude of observation, it is impossible to make an exact statement in the comparison of measures. It follows that a certain subset of closely allied congruence relations can be assigned of which each member equally well agrees with that statement of observed congruence when the statement is properly qualified within its limits of error. This is an entirely different question, and it presupposes a rejection of Poincaré's position. The absolute indetermination of nature in respect of all the relations of congruence is replaced by the indetermination of observation with respect to a small subgroup of these relations. Poincaré's position is a strong one. He in effect challenges anyone to point out any factor in nature which gives a preeminent status to the congruence relation which mankind has actually adopted. But undeniably the position is very paradoxical. Bertrand Russell had a controversy with him on this question, and pointed out that on Poincaré's principles there was nothing in nature to determine whether the earth is larger or smaller than some assigned billiard ball. Poincaré replied that the attempt to find relations in nature for the selection of a definitive congruence relation in space is like trying to determine the position of a ship in the ocean by counting the crew and observing the colour of the captain's eyes. In my opinion, both disputants were right, assuming the grounds on which the discussion was based. Russell, in effect, pointed out that apart from minor inexactitudes, a determinate congruence relation is among the factors in nature which our sense awareness posits for us. Poincaré asks for information as to the factor in nature which might lead any particular congruence relation to play a preeminent role among the factors posited in sense awareness. I cannot see the answer to either of these contentions, provided that you admit the materialistic theory of nature. With this theory, nature at an instant in space is an independent fact. Thus we have to look for our preeminent congruence relation amid nature in instantaneous space. And Poincaré is undoubtedly right in saying that nature on this hypothesis gives us no help in finding it. On the other hand, Russell is in an equally strong position when he asserts that, as a fact of observation, we do find it, and what is more, agree in finding the same congruence relation. On this basis, it is one of the most extraordinary facts of human experience that all mankind, without any assignable reason, should agree in fixing attention on just one congruence relation amid the indefinite number of indistinguishable competitors for notice. One would have expected disagreement on this fundamental choice to have divided nations and to have rent families. But the difficulty was not even discovered till the close of the 19th century by a few mathematical philosophers and philosophic mathematicians. The case is not like that of our agreement on some fundamental fact of nature such as the three dimensions of space. If space has only three dimensions, we should expect all mankind to be aware of the fact, as they are aware of it. But in the case of congruence, mankind agree in an arbitrary interpretation of sense awareness when there is nothing in nature to guide it. I look on it as no slight recommendation of the theory of nature which I am expounding to you, that it gives a solution of this difficulty by pointing out the factor in nature which issues in the preeminence of one congruence relation over the indefinite herd of other such relations. The reason for this result is that nature is no longer confined within space at an instant. Space and time are now interconnected, and this peculiar factor of time, which is so immediately distinguished among the deliverances of our sense awareness, relates itself to one particular congruence relation in space. Congruence is a particular example of the fundamental fact of recognition. In perception, we recognize. This recognition does not merely concern the comparison of a factor of nature posited by memory with a factor posited by immediate sense awareness. Recognition takes place within the present without any intervention of pure memory. For the present, fact is a duration with its antecedent and consequent durations which are parts of itself. The discrimination in sense awareness of a finite event with its quality of passage is also accompanied by the discrimination of other factors of nature which do not share in the passage of events. Whatever passes is an event. But we find entities in nature which do not pass. Namely, we recognize samenesses in nature. Recognition is not primarily an intellectual act of comparison. It is in its essence merely sense awareness in its capacity of positing before us factors in nature which do not pass. For example, green is perceived as situated in a certain finite event within the present duration. This green preserves its self-identity throughout, whereas the event passes and thereby obtains the property of breaking into parts. The green patch has parts, but in talking of the green patch, we are speaking of the event in its sole capacity of being for us the situation of green. The green itself is numerically one self-identical entity without parts, because it is without passage. Factors in nature which are without passage will be called objects. There are radically different kinds of objects which will be considered in the succeeding lecture. Recognition is reflected into the intellect as comparison. The recognized objects of one event are compared with the recognized objects of another event. The comparison may be between two events in the present, or it may be between two events of which one is posited by memory awareness and the other by immediate sense awareness. But it is not the events which are compared, for each event is essentially unique and incomparable. What are compared are the objects and relations of objects situated in events. The event considered as a relation between objects has lost its passage and in this aspect is itself an object. This object is not the event but only an intellectual abstraction. The same object can be situated in many events, and in this sense even the whole event viewed as an object can recur, though not the very event itself with its passage and its relations to other events. Objects which are not posited by sense awareness may be known to the intellect. For example, relations between objects and relations between relations may be factors in nature not disclosed in sense awareness, but known by logical inference as necessarily in being. Thus objects for our knowledge may be merely logical abstractions. For example, a complete event is never disclosed in sense awareness, and thus the object which is the sum total of objects situated in an event as thus interrelated is a mere abstract concept. Again, a right angle is a perceived object which can be situated in many events. But though rectangularity is posited by sense awareness, the majority of geometrical relations are not so posited. Also, rectangularity is in fact often not perceived when it can be proved to have been there for perception. Thus an object is often known merely as an abstract relation, not directly posited in sense awareness, although it is there in nature. The identity of quality between congruent segments is generally of this character. In certain special cases, this identity of quality can be directly perceived, but in general it is inferred by a process of measurement depending on our distinct sense awareness of selected cases and a logical inference from the transitive character of congruence. Congruence depends on motion, and thereby is generated the connection between spatial congruence and temporal congruence. Motion along a straight line has a symmetry round that line. This symmetry is expressed by the symmetrical geometrical relations of the line to the family of planes normal to it. Also, another symmetry in the theory of motion arises from the fact that rest in the points of beta corresponds to uniform motion along a definite family of parallel straight lines in the space of alpha. We must note the three characteristics: 1. Of the uniformity of the motion corresponding to any point of beta along its correlated straight line in alpha, and 2. Of the equality in magnitude of the velocities along the various lines of alpha correlated to rest in the various points of beta, and 3. Of the parallelism of the lines of this family. We are now in possession of a theory of parallels, and a theory of perpendiculars, and a theory of motion, and from these theories the theory of congruence can be constructed. It will be remembered that a family of parallel levels in any moment is the family of levels in which that moment is intersected by the family of moments of some other time system. Also, a family of parallel moments is the family of moments of some one time system. Thus we can enlarge our concept of a family of parallel levels so as to include levels in different moments of one time system. With this enlarged concept, we say that a complete family of parallel levels in a time system alpha is the complete family of levels in which the moments of alpha intersect the moments of beta. This complete family of parallel levels is also evidently a family lying in the moments of the time system beta. By introducing a third system, gamma, parallel rects are obtained. Also, all the points of any one time system form a family of parallel point tracks. Thus there are three types of parallelograms in the four-dimensional manifold of event particles. In parallelograms of the first type, the two pairs of parallel sides are both of them pairs of rects. In parallelograms of the second type, one pair of parallel sides is a pair of rects, and the other pair is a pair of point tracks. In parallelograms of the third type, the two pairs of parallel sides are both of them pairs of point tracks. The first axiom of congruence is that the opposite sides of any parallelogram are congruent. This axiom enables us to compare the lengths of any two segments either respectively on parallel rects or on the same rect. Also it enables us to compare the lengths of any two segments either respectively on parallel point tracks or on the same point track. It follows from this axiom that two objects at rest in any two points of a time system beta are moving with equal velocities in any other time system alpha along parallel lines. Thus we can speak of the velocity in alpha due to the time system beta without specifying any particular point in beta. The axiom also enables us to measure time in any time system, but does not enable us to compare times in different time systems. The second axiom of congruence concerns parallelograms on congruent bases and between the same parallels, which have also their other pairs of sides parallel. The axiom asserts that the rect joining the two event particles of intersection of the diagonals is parallel to the rect on which the bases lie. By the aid of this axiom, it easily follows that the diagonals of a parallelogram bisect each other. Congruence is extended in any space beyond parallel rects to all rects by two axioms depending on perpendicularity. The first of these axioms, which is the third axiom of congruence, is that if ABC is a triangle of rects in any moment, and D is the middle event particle of the base BC, then the level through D perpendicular to BC contains A when and only when AB is congruent to AC. This axiom evidently expresses the symmetry of perpendicularity and is the essence of the famous pons asinorum expressed as an axiom. The second axiom depending on perpendicularity, and the fourth axiom of congruence, is that if R and A be a rect, and an event particle in the same moment, and AB and AC be a pair of rectangular rects intersecting R in B and C, and AD and AE be another pair of rectangular rects intersecting R in D and E, then either D or E lies in the segment BC, and the other one of the two does not lie in this segment. Also, as a particular case of this axiom, if AB be perpendicular to R and in consequence AC be parallel to R, then D and E lie on opposite sides of B respectively. By the aid of these two axioms, the theory of congruence can be extended so as to compare lengths of segments on any two rects. Accordingly, Euclidean metrical geometry in space is completely established, and lengths in the spaces of different time systems are comparable as the result of definite properties of nature which indicate just that particular method of comparison. The comparison of time measurements in diverse time systems requires two other axioms. The first of these axioms, forming the fifth axiom of congruence, will be called the axiom of kinetic symmetry. It expresses the symmetry of the quantitative relations between two time systems when the times and lengths in the two systems are measured in congruent units. The axiom can be explained as follows. Let alpha and beta be the names of two time systems. The directions of motion in the space of alpha due to rest in a point of beta is called the beta direction in alpha, and the direction of motion in the space of beta due to rest in a point of alpha is called the alpha direction in beta. Consider a motion in the space of alpha consisting of a certain velocity in the beta direction of alpha and a certain velocity at right angles to it. This motion represents rest in the space of another time system. Call it π. Rest in π will also be represented in the space of beta by a certain velocity in the alpha direction in beta and a certain velocity at right angles to this alpha direction. Thus a certain motion in the space of alpha is correlated to a certain motion in the space of beta, as both representing the same fact which can also be represented by rest in π. Now another time system which I will call sigma can be found which is such that rest in its space is represented by the same magnitudes of velocities along and perpendicular to the alpha direction in beta as those velocities in alpha along and perpendicular to the beta direction, which represent rest in π. The required axiom of kinetic symmetry is that rest in sigma will be represented in alpha by the same velocities along and perpendicular to the beta direction in alpha as those velocities in beta along and perpendicular to the alpha direction which represent rest in π. A particular case of this axiom is that relative velocities are equal and opposite. Namely, rest in alpha is represented in beta by a velocity along the alpha direction which is equal to the velocity along the beta direction in alpha which represents rest in beta. Finally, the sixth axiom of congruence is that the relation of congruence is transitive. So far as this axiom applies to space, it is superfluous, for the property follows from our previous axioms. It is, however, necessary for time as a supplement to the axiom of kinetic symmetry. The meaning of the axiom is that if the time unit of system alpha is congruent to the time unit of system beta, and the time unit of system beta is congruent to the time unit of system gamma, then the time units of alpha and gamma are also congruent. By means of these axioms, formulae for the transformation of measurements made in one time system to measurements of the same facts of nature made in another time system can be deduced. These formulae will be found to involve one arbitrary constant which I will call kappa. It is of the dimensions of the square of a velocity. Accordingly, four cases arise. In the first case, kappa is 0. This case produces nonsensical results in opposition to the elementary deliverances of experience. We can put this case aside. In the second case, kappa is infinite. This case yields the ordinary formulae for transformation in relative motion, namely those formulae which are to be found in every elementary book on dynamics. In the third case, kappa is negative. Let us call it negative c squared, where c will be the dimensions of a velocity. This case yields the formulae of transformation which Larmor discovered for the transformation of Maxwell's equations of the electromagnetic field. These formulae were extended by H.A. Lorentz and used by Einstein and Minkowski as the basis of their novel theory of relativity. I am not now speaking of Einstein's more recent theory of general relativity, by which he deduces his modification of the law of gravitation. If this be the case which applies to nature, then c must be a close approximation to the velocity of light in vacuo. Perhaps it is this actual velocity. In this connection, in vacuo must not mean an absence of events, namely the absence of the all-pervading ether of events. It must mean the absence of certain types of objects. In the fourth case, kappa is positive. Let us call it h2, where h will be of the dimensions of a velocity. This gives a perfectly possible type of transformation formulae, but not one which explains any facts of experience. It has also another disadvantage. With the assumption of this fourth case, the distinction between space and time becomes unduly blurred. The whole object of these lectures has been to enforce the doctrine that space and time spring from a common root, and that the ultimate fact of experience is a space-time fact. But after all, mankind does distinguish very sharply between space and time, and it is owing to this sharpness of distinction that the doctrine of these letters is somewhat of a paradox. Now in the third assumption this sharpness of distinction is adequately preserved. There is a fundamental distinction between the metrical properties of point tracks and rects. But in the fourth assumption this fundamental distinction vanishes. Neither the third nor the fourth assumption can agree with experience unless we assume that the velocity c of the third assumption and the velocity h of the fourth assumption are extremely large compared to the velocities of ordinary experience. It must be the case the formulae of both assumptions will obviously reduce to a close approximation to the formulae of the second assumption, which are the ordinary formulae of dynamical textbooks. For the sake of a name, I will call these textbook formulae the orthodox formulae. There can be no question as to the general correctness of the orthodox formulae. It would be merely silly to raise doubts on this point, but the determination of the status of these formulae is by no means settled by this admission. The independence of time and space is an unquestioned presupposition of the orthodox thought which has produced the orthodox formulae. With this presupposition, and given the absolute points of one absolute space, the orthodox formulae are immediate deductions. Accordingly, these formulae are presented to our imaginations as facts which cannot be otherwise, time and space being what they are. The orthodox formulae have therefore attained to the status of necessities which cannot be questioned in science. Any attempt to replace these formulae by others was to abandon the role of physical explanation and to have recourse to mere mathematical formulae. But even in physical science, difficulties have accumulated round the orthodox formulae. In the first place, Maxwell's equations of the electromagnetic field are not invariant for the transformations of the orthodox formulae, whereas they are invariant for the transformations of the formulae arising from the third of the four cases mentioned above, provided that the velocity c is identified with the famous electromagnetic constant quantity. Again, the null results of the delicate experiments to detect the earth's variations of motion through the ether in its orbital path are explained immediately by the formulae of the third case. But if we assume the orthodox formulae, we have to make a special and arbitrary assumption as to the contraction of matter during motion. I mean the Fitzgerald-Lorentz assumption. Lastly, Fresnel's coefficient of drag, which represents the variation of the velocity of light in a moving medium, is explained by the formulae of the third case and requires another arbitrary assumption if we use the orthodox formulae. It appears therefore that on the mere basis of physical explanation there are advantages in the formulae of the third case as compared with the orthodox formulae. But the way is blocked by the ingrained belief that these latter formulae possess a character of necessity. It is therefore an urgent requisite for physical science and for philosophy to examine critically the grounds for this supposed necessity. The only satisfactory method of scrutiny is to recur to the first principles of our knowledge of nature. This is exactly what I am attempting to do in these lectures. I ask what it is that we are aware of in our sense perception of nature. I then proceed to examine those factors in nature which lead us to conceive nature as occupying space and persisting through time. This procedure has led to an investigation of the characters of space and time. It results from these investigations that the formulae of the third case and the orthodox formulae are on a level as possible formulae resulting from the basic character of our knowledge of nature. The orthodox formulae have thus lost any advantage as to necessity which they enjoyed over the serial group. The way is thus open to adopt whichever of the two groups best accords with observation. I take this opportunity of pausing for a moment from the course of my argument and of reflecting on the general character which my doctrine ascribes to some familiar concepts of science. I have no doubt that some of you have felt that in certain aspects this character is very paradoxical. This vein of paradox is partly due to the fact that educated language has been made to conform to the prevalent orthodox theory. We are thus, in expounding an alternative doctrine, driven to the use of either strange terms or of familiar words with unusual meanings. This victory of the orthodox theory over language is very natural. Events are named after the prominent objects situated in them, and thus both in language and in thought the event sinks behind the object and becomes the mere play of its relations. The theory of space is then converted into a theory of relations of objects instead of a theory of the relations of events. But objects have not the passage of events. Accordingly, space as a relation between objects is devoid of any connection with time. It is space at an instant without any determinate relations between the spaces at successive instants. It cannot be one timeless space because the relations between objects change. A few minutes ago, in speaking of the deduction of the orthodox formulae for relative motion, I said that they followed as an immediate deduction from the assumption of absolute points in absolute space. This reference to absolute space was not an oversight. I know that the doctrine of the relativity of space at present holds the field both in science and philosophy, but I do not think that its inevitable consequences are understood. When we face them, the paradox of the presentation of the character of space which I have elaborated is greatly mitigated. If there is no absolute position, a point must cease to be a simple entity. What is a point to one man in a balloon with his eyes fixed on an instrument is a track of points to an observer on the earth who is watching the balloon through a telescope, and is another track of points to an observer in the sun who is watching the balloon through some instrument suited to such a being. Accordingly, if I am reproached with the paradox of my theory of points as classes of event particles, and of my theory of event particles as groups of abstractive sets, I ask my critic to explain exactly what he means by a point. While you explain your meaning about anything, however simple, it is always apt to look subtle and fine-spun. I have at least explained exactly what I do mean by a point, what relations it involves, and what entities are the relata. If you admit the relativity of space, you also must admit that points are complex entities, logical constructs involving other entities and their relations. Produce your theory not in a few vague phrases of indefinite meaning, but explain it step by step in definite terms referring to assigned relations and assigned relata. Also show that your theory of points issues in a theory of space. Furthermore, note that the example of the man in the balloon and the observer on earth and the observer in the sun shows that every assumption of relative rest requires a timeless space with radically different points from those which issue from every other such assumption. The theory of the relativity of space is inconsistent with any doctrine of one unique set of points of one timeless space. The fact is that there is no paradox in my doctrine of the nature of space which is not in essence inherent in the theory of the relativity of space. But this doctrine has never really been accepted in science, whatever people say. What appears in our dynamical treatises is Newton's doctrine of relative motion based on the doctrine of differential motion in absolute space. When you once admit that the points are radically different entities for differing assumptions of rest, then the orthodox formulae lose all their obviousness. They were only obvious because you were really thinking of something else. When discussing this topic you can only avoid paradox by taking refuge from the flood of criticism in the comfortable ark of no meaning. The new theory provides a definition of the congruence of periods of time. The prevalent view provides no such definition. Its position is that if we take such time measurements so that familiar velocities will seem to us to be are uniform, then the laws of motion are true. Now, in the first place, no change could appear either as uniform or non-uniform without involving a definite determination of the congruence for time periods. So in appealing to familiar phenomena, it allows that there is some factor in nature which we can intellectually construct as a congruence theory. It does not, however, say anything about it except that the laws of motion are then true. Suppose that with some expositors we cut out the reference to familiar velocities, such as the rate of rotation of the earth. We are then driven to admit that there is no meaning in temporal congruence, except that certain assumptions make the laws of motion true. Such a statement is historically false. King Alfred the Great was ignorant of the laws of motion, but knew very well what he meant by the measurement of time, and achieved his purpose by means of burning candles. Also, no one in past ages justified the use of sand in hourglasses by saying that some centuries later interesting laws of motion would be discovered which would give a meaning to the statement that sand was emptied from the bulbs in equal times. Uniformity in change is directly perceived, and it follows that mankind perceives in nature factors from which a theory of temporal congruence can be formed. The prevalent theory entirely fails to produce such factors. The mention of the laws of motion raises another point where the prevalent theory has nothing to say and the new theory gives a complete explanation. It is well known that the laws of motion are not valid for any axes of reference which you may choose to take fixed in any rigid body. You must choose a body which is not rotating and has no acceleration. For example, they do not really apply to axes fixed in the earth because of the diurnal rotation of that body. The law which fails when you assume the wrong axes as at rest is the third law, that action and reaction are equal and opposite. With the wrong axes uncompensated centrifugal forces and uncompensated composite centrifugal forces appear due to rotation. The influence of these forces can be demonstrated by many facts on the earth's surface. Foucault's pendulum, the shape of the earth, the fixed directions of the rotations of cyclones and anticyclones. It is difficult to take seriously the suggestion that these domestic phenomena on the earth are due to the influence of the fixed stars. I cannot persuade myself to believe that a little star in its twinkling turned round Foucault's pendulum in the Paris exhibition of 1861. Of course anything is believable when a definite physical connection has been demonstrated, for example the influence of sunspots. Here all demonstration is lacking in the form of any coherent theory. According to the theory of these lectures, the axes to which motion is to be referred are axes at rest in the space of some time system. For example, consider the space of a time system alpha. There are sets of axes at rest in the space of alpha. These are suitable dynamical axes. Also a set of axes in this space which is moving with uniform velocity without rotation is another suitable set. All the moving points fixed in these moving axes are really tracing out parallel lines with one uniform velocity. In other words, they are reflections in the space of alpha of a set of fixed axes in the space of some other time system beta. Accordingly, the group of dynamical axes required for Newton's laws of motion is the outcome of the necessity of referring motion to a body at rest in the space of some one time system in order to obtain a coherent account of physical properties. If we do not do so, the meaning of the motion of one portion of our physical configuration is different from the meaning of the motion of another portion of the same configuration. Thus the meaning of motion being what it is, in order to describe the motion of any system of objects without changing the meaning of your terms as you proceed with your description, you are bound to take one of these sets of axes as axes of reference, though you may choose their reflections into the space of any time system which you wish to adopt. A definite physical reason is thereby assigned for the peculiar property of the dynamical group of axes. On the orthodox theory, the position of the equations of motion is most ambiguous. The space to which they refer is completely undetermined, and so is the measurement of the lapse of time. Science is simply setting out on a fishing expedition to see whether it cannot find some procedure which it can call the measurement of space, and some procedure which it can call the measurement of time, and something which it can call a system of forces, and something which it can call masses, so that these formulae may be satisfied. The only reason, on this theory, why anyone should want to satisfy these formulae is a sentimental regard for Galileo, Newton, Euler, and Lagrange. The theory, so far from founding science on a sound observational basis, forces everything to conform to a mere mathematical preference for certain simple formulae. I do not for a moment believe that this is a true account of the real status of the laws of motion. These equations want some slight adjustment for the new formulae of relativity. But with these adjustments, imperceptible in ordinary use, the laws deal with fundamental physical quantities which we know very well and wish to correlate. The measurement of time was known to all civilized nations long before the laws were thought of. It is this time, as thus measured, that the laws are concerned with. Also they deal with the space of our daily life. When we approach to an accuracy of measurement beyond that of observation, adjustment is allowable. But within the limits of observation, we know what we mean when we speak of measurements of space and measurements of time and uniformity of change. It is for science to give an intellectual account of what is so evident in sense awareness. It is to me thoroughly incredible that the ultimate fact beyond which there is no deeper explanation is that mankind has really been swayed by an unconscious desire to satisfy the mathematical formulae which we call the laws of motion, formulae completely unknown till the 17th century of our epoch. The correlation of the facts of sense experience effected by the alternative account of nature extends beyond the physical properties of motion and the properties of congruence. It gives an account of the meaning of the geometrical entities such as points, straight lines, and volumes, and connects the kindred ideas of extension in time and extension in space. The theory satisfies the true purpose of an intellectual explanation in the sphere of natural philosophy. This purpose is to exhibit the interconnections of nature and to show that one set of ingredients in nature requires for the exhibition of its character the presence of the other set of ingredients. The false idea which we have to get rid of is that of nature as a mere aggregate of independent entities, each capable of isolation. According to this conception, these entities, whose characters are capable of isolated definition, come together and by their accidental relations form the system of nature. This system is thus thoroughly accidental, and even if it be subject to a mechanical fate, it is only accidentally so subject. With this theory, space might be without time, and time might be without space. The theory admittedly breaks down when we come to the relations of matter and space. The relational theory of space is an admission that we cannot know space without matter or matter without space. But the seclusion of both from time is still jealously guarded. The relations between portions of matter in space are accidental facts owing to the absence of any coherent account of how space springs from matter or how matter springs from space. Also, what we really observe in nature, its colours and its sounds and its touches, are secondary qualities. In other words, they are not in nature at all, but are accidental products of the relations between nature and mind. The explanation of nature which I urge as an alternative ideal to this accidental view of nature is that nothing in nature could be what it is except as an ingredient in nature as it is. The whole which is present for discrimination is posited in sense awareness as necessary for the discriminated parts. An isolated event is not an event because every event is a factor in a larger whole and is significant of that whole. There can be no time apart from space, and no space apart from time, and no space and no time apart from the passage of the events of nature. The isolation of an entity in thought, when we think of it as a bare 'it', has no counterpart in any corresponding isolation in nature. Such isolation is merely part of the procedure of intellectual knowledge. The laws of nature are the outcome of the characters of the entities which we find in nature. The entities being what they are, the laws must be what they are, and conversely the entities follow from the laws. We are a long way from the attainment of such an ideal, but it remains as the abiding goal of theoretical science. End of chapter 6.